Hello, everyone. I'm Spectre. With me is Z. Welcome to the Star Wars edition of the dayzero podcast. No, the reason I'm saying that is happy Star Wars Day to anybody who celebrates that. I know we're a few minutes late today because we've been having some fun technical issues both on our side and on Twitch's side. It seems the Twitch API is having some issues right now. And also apologies if, like, at some points I sound a little bit, unenthused compared to normal on the podcast, because I do have a bit of a headache that just sprung up before the podcast. It's like everything's trying to compound today, so it's been a fun day for pre-stream. But we will jump into talking about some stuff. Before we get into news, though, I think we'll do a bit of a summary on decompilers, because over the last couple weeks we've been talking a lot about the Binja decompiler that recently dropped. And during last week, we were analyzing the Realize decompiler we did a stream about. So I think we want to do like a summary of some of the points that we had for both Realize and Binja, and we figured we'd kind of, plug that in to the beginning of this episode.
Just a quick summary there, because I don't think most people are going to be too enthused about watching, I don't know, what do we have, 8-9 hours worth of streaming between the two of them? I think both of those streams were around 4 hours.
Yeah, both of them were almost 4 hours on the nose. So, yeah, they were quite long streams. And part of the reason for that is we had a lot of discussion with Binja Dev that joined us for both streams, which is really cool. There's actually some really insightful discussion there for anybody who wants to check out the VODs. Maybe it is worth like going back and clipping some of those discussions, because some people might find them interesting. But yeah, it is like they are quite long streams, so we are going to do like a bit of a summary here. So I think we'll start with Realize, just because we covered that this week. So some of the points that we noticed, I have a few like negative and positive points that were summarized from the stream.
Before you jump to the points, I do want to offer one correction on something I had stated last stream when we were talking about Realize, which was just about being able to copy out code. Apparently that you can do it, and like I said, I figured that was probably a user error. What was it? It was a right click, and then it was under a sub menu. I think you had found it, Spectre.
Yeah, you had to right click on it, and it was copy as text or something like that.
I think it was still under a sub menu yet, then copy as text or export, I think.
Yeah, it might have been export. Yeah. I mean, to say what you were saying, Laird, with like a user error, kind of a user error, but at the same time, I think that is very unintuitive. And that is one thing I found with Realize, is there's a few things that should be more intuitive to the user experience that are not. So you can do them, but you have to kind of go digging to know that you can do them and know how to do them. So I do think there needs to be some work on like the UI and the UX there. To make Realize more intuitive to use. But I guess I'll jump into some of the points. So first I'll cover some of the things that I found were an issue. One of them was structure accesses wouldn't get rewritten when you change the type of a variable to a structure. So if you by default, when you have an array, or sorry, not an array, if you have a structure, it gets written as an array in the decompiler output. But in Binja, for example, if you change the type of that variable from an array to a structure, it'll rewrite all the accesses on that, whereas Realize doesn't actually do that. So there's a bit of a weird thing there where it doesn't rewrite the decompiler output. The other thing I found was the casting with signedness was wrong sometimes. They don't have any constant propagation, so while they allow you to use enumerated types, they don't really do anything. And the biggest gripe I think that I had with it was with C++ stuff, class member names work, but you can't use the standard library when you define classes for your types. So the problem with that is if you have a class for something you're reversing that has like a standard lib string or anything like that, like a vector, a string, anything like that, you're not going to be able to put that into Realize. At least I couldn't seem to get it in there.
Yeah, and that's definitely like an annoying part of it. At the same time, like, I'm sure some of those structures are going to be quite complex for them to just kind of have built in.
But at the same time, standard lib is pretty common.
Oh yeah, no, I completely agree. Like, I don't actually know what like IDA support is for that. Do you know offhand? I haven't done a ton of C++ RE.
Yeah, I'm not into C++ RE. I actually hate it. So I haven't really tried it in IDA either, so that is a fair point. I don't know how Hexrace handles that. It might have the same issue, or it might not even. Like, it might be even worse. I can't speak on that. And I think when we did Binja, we kind of neglected the C++ a little bit more. So, to be fair to Realize, it could just be something that I noticed on the Realize stream, but I didn't really test much on some other decompilers. So there could be a bit of a bias there. Overall, though, there were some positives with Realize for sure. For one, it had some really nice optimization on dead functions, and it was so nice actually that I wanted to double check that it wasn't overly aggressive, which it wasn't in my tests. They have a really nice filter search panel, which I really liked. You can do like a filter search and search all the columns and stuff like that. It's a little bit more advanced. It's kind of like Ghidra's search actually. And I think the other thing is it handled stack checks or like stack cookie checks really well. So sometimes like Binary Ninja would leave out stack cookie checks. It would just omit them. Ghidra would sometimes just omit them, or it would like mess up the analysis. But with Realize, they were like there, plain as day. It even had a little bit of constant propagation with that as well. So yeah, overall, they had some positives. There were a few negatives, but like we were saying on the stream, Realize is one of those things where the decompiler, at least for free, just dropped. And it's more mature than Binary Ninja's decompiler, like as in it's been around for longer. But it's not as old as Hexrace, you know what I mean? So I don't expect it to compete with Hexrace yet. You know, I don't think it's at that level. So since we've kind of summarized Realize there, I will give like a bit of a recap on some of the Binja stuff and what it did better than Realize, which was it handled rewriting better for decompiling. It was more intuitive to use because the UX, I think, was done better on Binja. And there was constant propagation, though it was a little bit too aggressive. But yeah, I can't remember if it had the C++ class stuff like Realize did. I can't say for sure.
I don't believe we really tried with that. I think we played around with some vtable stuff and some of that, just see how the decompiler handled it, but not so much at the structure level and just using it. So I can't speak offhand for that. I will say that one of the things you liked about the dead code elimination was basically when it would take a function that did nothing but return a constant and basically just pop that in place, and Binja does do the same thing.
Yeah. So, I mean, I think I will go back this week and check out Binja and see if it does that class stuff. I'm not going to do a stream on it because it's just one thing I want to check, and then I'll probably do like a correction next stream or like a, addendum or whatever. But yeah, I think we're going to also write a more detailed blog post at some point that breaks the stuff down more and gives examples and stuff like that. I also haven't published that corpus repository that I was working on, so I got to clean that up a little bit and push that out. So we are going to be doing a blog post, more structured blog post on it soon.
Yeah, probably targeting closer to after Binja stable has the decompiler.
Yeah, it's probably
which is, I think, kind of coming towards the end of the month or so.
I think end of May was when they were aiming for. So yeah, so we'll do that more structured blog post. Take a look out for that. But if you want to, see some of our thoughts and insights on it before that blog post goes out, the Twitch VODs will be up for a little while. I think usually they stay up for at least 30 days. So the Binja one is a little bit older, but the Realize one will be up for a while. So you can check those out while they're still up. And I think I will do like a stream cut on the YouTube channel for anybody who wants some of the highlights from that, basically. But with that said, we'll move on to some news. We actually only have one news topic before we jump into some exploits this week. And it's kind of a follow-up to stories we talked about before with the NSO Group and Facebook. So there's a lawsuit going on. Facebook is suing the NSO Group, I think, over their WhatsApp stuff. They're claiming that NSO Group basically breached WhatsApp through a vulnerability that their spyware used.
There are a few different things that kind of go into that. I believe it actually comes up, but there's two, because you have to remember, breaching, that's criminal. That's not something that you're going to be sued in civil court over. That's like Computer Fraud and Abuse Act. Whereas this is more of their civil court. I believe it does mention kind of the specifics over what they were suing over. That said, I only really want to talk about a couple of things that kind of come up out of this, or come up out of NSO Group's most recent filing. I don't know what you had to mention, but one of the things was this comment on immunity, where NSO Group is basically arguing that because their customers are governments, they're effectively immune to any sort of litigation. Now, it mentions here, whether or not sovereign immunity applies to them. I think that might actually, I think they might be meaning to refer to state immunity, which it applies to kind of foreign governments. That said, I'm not a lawyer, you're not a lawyer, so, this is purely just us talking about it. No real understanding of all the legal stuff. But I did find that kind of an interesting idea that as a company, if they're selling to a government, they're somehow possibly immune.
That seems weird to me. Like, why?
Yeah,
just because governments enforce the law doesn't mean they're above it in terms of
Well, so at least with sovereign immunity, though, is pretty much exactly that. Because all criminal charges are, because you can sue the government. I believe. I'm actually not completely certain about that. I know you can sue. I believe you can sue parts of the government, such as the DOJ, when somebody's been imprisoned and then
falsely
proven,
or something like that.
Falsely in prison. That said, I'm not sure about the actual government, but when you go into criminal court, it's always, in the US, it's the US versus whoever's being charged with something. So taking, the US to criminal court is, the US versus the US. So
Spider-Man meme.
You can kind of understand where some immunity comes in. You might be able to apply to some specific individuals, but not to the government itself. So at least that's some idea of the immunity. And then, like I mentioned, the state immunity is just basically kind of a truce between countries that you're not going to start suing each other or charging each other kind of at that level, which, I mean, a country doesn't really have the ability to enforce anything against the other country anyhow.
Yes.
So, I mean, the immunity sense does make some sense. It's just, one is NSO Group because they're, you can look at them as kind of being government contractors. They also mentioned that, they don't run the Pegasus software for their clients, so any of the actions involved wouldn't have been from them.
Yeah, I think that's their big argument, right? Is they're arguing that, the CFAA, they're arguing, only applies to unauthorized access, not malicious content. So
that's actually a separate argument. So there's two things going on here. There's the immunity claim. They're claiming that they're immune. Then
but the other one is the one I was just saying with the malicious content.
Yeah, it's separate. Them not running Pegasus
separate arguments.
Doesn't really matter with that. But yeah, as you were saying, one of the comments in here is NSO Group insists it cannot have violated America's Computer Fraud and Abuse Act because it had authorization to send messages via WhatsApp. And this is kind of one of the comments I thought was most interesting. First of all, it is always worth mentioning when it comes to the law, there is a judge usually that's actually interpreting the law, or a jury. You don't get to just play around on a law of the really minor technicalities when something's written in a way that makes it somewhat obvious. There are still technicalities, of course, that lawyers can play around with, but... And I do think this one might actually be one of those cases. It's an interesting point, being that they were authorized to send messages because no compromise, at least that was brought up initially, involved WhatsApp servers besides just WhatsApp facilitating the compromise. It was compromising somebody's phone. Ignoring the fact that NSO claimed that they don't run the software, it would have been somebody else actually doing that. The idea being they're allowed to send messages, WhatsApp terms of service doesn't prevent them from sending malicious messages.
Yeah, they basically all they did was send the wrong kind of messages over WhatsApp servers.
Yeah.
So I mean, it's an interesting argument. Like you said, it is it is getting like pretty into the technicality weeds, but like what's interesting, especially when you're talking about like the legal system in court, when you're talking about technology, is most judges. There probably are certain judges that are kind of cut out for technical stuff, but for the most part, judges aren't really gonna appreciate those technical differences just because they're not overly familiar with like the exploitation area. It's kind of one of those areas where you have to be familiar with it to be able to understand all the intricacies of what's going on.
Yeah,
it's not like an everyday thing that a judge or a jury would encounter in their everyday life.
No, but
it's pretty niche.
That's the point of expert witnesses, to explain that to the judge, to explain that to the jury, so that they are able to understand what they need to about it. I wouldn't expect the judge to understand it. I would expect a judge or jury to listen to an expert witness who explains some of those details to them. I wouldn't think that the law can't be upheld because a judge doesn't know that. Like, they don't need to know, or they don't need to already go in there with that information. They just need to be able to listen to presumably an expert acting in good faith.
So, I mean, like you said, like neither of us are really lawyers. I don't think we can speak to the, how effective these arguments are or anything like that. But the reason we wanted to bring it up was like this is probably going to be a bedrock case for future computer fraud and abuse acts, because the way the legal system is, from what I understand, is a lot of cases are built on top of other cases. It's kind of like a brick wall, and each case
precedents,
closed, you get up putting a brick in that wall, and everything after that kind of will reference that case. And I think this is going to be one of those bedrock cases that's going to be used in future lawsuits.
Yeah, and that's kind of just in the US, the legal system is very precedence based, where if there's kind of the past precedence for doing something, a judge needs a reason to deviate from the decision of another court. Well, not of an equal court, but as I'm sure whatever happens, it's going to get appealed either way. So as it moves its way up the courts, kind of has that the precedent gets set. That said, other countries don't quite work like that. Like, precedence has less of a meaning.
Yeah.
That said,
it'll be interesting to keep like an eye on it and see how it goes in the future.
Yeah, it's definitely a major case for the time. And we talked about it previously, so figured we'd give kind of another update. And it was actually, I believe, Razzie Wu that actually dropped the link for us in the Discord.
So we'll move into some exploits. Our first one is command injection in Netsweeper. So this was posted on SSD Disclosure. So it was reported through them, but the vendor rejected and ignored the reports, apparently to this day. So I don't know what's going on there. Like, it's just weird that they're just rejecting it. So they decided to do a full disclosure, which is kind of interesting. We'll probably get to that later on after we cover the issue. Essentially, it seems the issue is that they have a vulnerable endpoint, which takes a login, a password, and a timeout, and then it checks the referrer header against an array of like different valid endpoints. And if the referrer is in that array, it executes a command using the login and password variables. And the password variable seems to just get concatenated into a string passed to the Python interpreter for doing crypto.
Well, injected into the string. We'll pull up the code here. Yeah, it's kind of in the middle there. It's the $2. Because it gets sent, like, they do escape the password. So obviously it's a PHP endpoint that this is submitted to. They escape both the login, the username, and the password. And they send those two things as arguments to the service.sh file. And in that service.sh file, though, it takes the second argument, the password, passes it into Python crypt. To try and generate like the proper hash for it, which then you can of course just escape right from. Do the basically finish out the command there with another single quote, colon or comma, and go on from there. What I found kind of interesting is just the fun fact that you're exploiting a PHP app and you're getting Python code injection.
Yeah. So here's the thing I found weird. I don't know if you can answer this, C, because I tried reading through the write-up to see if I missed something, and I couldn't really find it. If you look at the code snippet slightly above where you are now, it has the password variable set by it does escape shell arg around the password. So am I missing something? Because is that just not sufficient? I'm guessing it's just not sufficient enough to prevent the.
No, it's sufficient. It prevents command injection. It prevents you from escaping. But like I said, it's the actual injection happens in service.sh. It doesn't happen where the PHP is calling service.sh.
Okay, I see what you mean.
So this escapes it as it's being passed into service.sh. So like the command injection, so there's going to be like a shell execute or something like that with this whole command. I'm not sure if they show. Yeah, I don't think they show what that line looks like, but there's going to be a shell execute with.
Yeah, they leave some lines out, which is why I think I got a little bit confused there.
Yeah, which is fair, but so they do shell execute with it. They have command, auth check, and then the login and password. It's then the service.sh file uses that password again and injects it into the call to Python to run that Python code. So it's where service.sh does it, that it doesn't do any escaping there. It just uses it directly. So that's why they're able to escape.
Okay. So overall, I mean, it's a command injection, so it's not a super technical issue. But getting back into the disclosure stuff, it seems there was a Reddit post from the person who was actually behind the disclosure, and they said they tried for 3 weeks to get a response over email. I think they tried 2 different emails. They tried support and sales, I think. They tried reaching out through Twitter, and they got basically, it seems, radio silence for 3 weeks. So it was just they just decided to disclose it. Which do you think that's fair, Z? Do you think they should have waited a little bit longer? 3 weeks does seem a little bit short when you're talking about trying to disclose issues, because sometimes vendors do take a little bit longer than that, even well-known ones. So I was kind of curious if you think the 3 weeks was a fair enough time window for expecting a response.
Well, I've kind of meant, so I do believe, and I feel like I have to kind of keep repeating myself through some of these different episodes, because, we have the same discussion a lot.
Well, I know your thoughts on disclosure. I know you think the threat of disclosure needs to be there. I'm just wondering if you think they should have waited longer. That's all.
I mean, in that sense, you have no response. 3 weeks, no response whatsoever, is frankly just unacceptable from any company. I mean, there should at the very least be a thank you for reporting, we'll look. It doesn't take much time. There's zero information there. I can kind of understand the 3 weeks. Now, I do recall we had another case where I want to say it was sub week with no response. And that, I don't think is fair. 3 weeks is short, but 3 weeks of absolutely no feedback. You're probably not hearing anything back if you wait further weeks. I could understand waiting more. I'm not going to hold it against somebody going public at this point, especially when we're talking about I believe this an unauthenticated code injection. That I think about, though, that might not be the case.
No, I think it is through the login, right?
It's through this Unix login page, which is kind of part of the tools there. It's not the main login.
Yeah, but usually endpoints like that are still accessible from.
Well, I think because this probably has to do with the servers being managed through here. So I could understand that being an admin endpoint. So maybe not. I don't know if it's unauthenticated or not.
Yeah, see, the only reason I brought that up with like is 3 weeks enough time is because the basically industry wide standard is 90-day disclosure deadline.
I mean, that's
But
only
that
good.
is
That's Project Zero does 90 days.
but they kind of set the standard on that. You know what I mean? They kind of a lot of people adhere to that as like a reasonable amount of time. But
A lot
that
of places do
is
30 days, though. 30 days was fairly common and still is pretty common, as is 60.
okay. But even if we stick to like 90 days, that is usually assuming you've received a response and they're saying they're working on a fix. And then if 90 days after the first report, it's not fixed, then you disclose it. Here, you're not getting a response at all. So I think it's more reasonable to not wait a full 90 days. So yeah, I'm kind of in agreement. I think 3 weeks is a reasonable amount of time to expect some kind of response. So I was just kind of curious if you would have like a different point of view on that. Did you want to add anything on there? I know I kind of cut you off earlier there.
Nope.
So yeah, I think we'll move on to SaltStack. So this is kind of one of our more headlining topics. So this was published by F-Secure Labs, and it details 2 vulnerabilities in SaltStack. It's an authentication bypass and a directory traversal, which we have a lot of in this episode. So SaltStack is a digital infrastructure management product, and it actually seems to target security, funnily enough. And the first issue is there's a class called ClearFuncs, which exposes these 2 methods, sendPub and PrepAuthInfo. And it seems these methods are exposed to unauthenticated requests.
Yeah, so I just pulled up, actually, some of the code. This is, I believe, I should have taken note. I believe this is a commit before they fix the issue that I've just kind of pulled up. And the basic idea here with ClearFuncs is, well, actually, with this whole area of code in general, is you're able to send in your commands, and it essentially, because they also do this with just their AES encrypted commands, and ClearFuncs in particular are the commands accessible without authentication that are available in the clear. And the way they do this is basically you send the payload properly, it parses it, however that looks. I didn't look into how it receives it. I just looked at how it processes these commands. And it basically just ends up calling the function on itself. Notice this line 1154. Where it just kind of grabs the attribute of whatever the command is and calls it as a function. So with that, this ClearFuncs, if we can actually find the class, effectively all of these classes, ClearFuncs, there it is, they define just basically the commands, runner, wheel, and these are all just whatever commands they're wanting to expose that people can simply run. And actually, if you look back at the line of code, what they do didn't come up. Where were we at? 1159, I think, sounds about right.
1154, I think, was around where you were.
And you can't Control F for the line numbers apparently here. But anyway, you'll notice here on 1149, if command starts with double underscore, that's their security. Any function that they don't want you to be able to run, but that they want to create in the class, starts with a double underscore, which is then the problem because they have, as Spectre was just mentioning, there are the 2 commands, the PrepAuthInfo and sendPub. Both of those are single underscores before them. Which means somebody, even though it's not necessarily documented, can simply call either of those functions and use them. So I'll mention PrepAuthInfo in particular basically just returns the root key that's used to authenticate the commands. So you can remotely call admin commands on like the master server using that key. It just returns that to you to use for whatever joyous purpose you have. SendPub, on the other hand, is basically to send messages out to either back to the, well, I'm going to assume things go through the master regardless. But effectively, it does the same thing. It results in code execution. usually, like, it'll use sendPub and it'll kind of craft the message in one of those functions I'll send, and it'll just send it off there. But by calling it directly, you can craft any sort of administrative message you want. What's kind of interesting here is this was used by Lineage OS. I don't know. Did you have anything more to add about the vulnerability itself, Spectre?
No, you covered it pretty well there, but I was actually going to say exactly what you're jumping into now, is we've actually seen that this is being abused against like projects in the wild right now, and you were saying like Lineage OS.
Yeah, so this particular post from F-Secure Labs, so they don't have a date on it, but it was fairly recent. But SaltStack, actually, I was going to talk about them last week because they put out the announcement, basically, don't expose these servers to the internet. They didn't say what the issue was, just don't expose it. And then they had this further update now where they've updated, they've fixed, and all of that. Anyway, so Lineage OS, they use SaltStack. And on May 2nd, so just a couple of days ago, an attacker used, it just says ACV, presumably it's this CV, to gain access to their infrastructure. So I noticed in kind of the comments that I probably should have actually linked right to the comment that I wanted.
Yeah, I think
here it is,
Sami
though.
Singh was the one you were looking for.
Yeah, mentions, the CV was publicly disclosed a week ago and recommended that you close off all publicly available salt stacks. The fact that this attack happened yesterday, this was written obviously yesterday, so then yesterday to it, means that you had 6 days when you could have preemptively stopped this from happening. And I thought that was kind of an interesting point here. So obviously I don't want to, sit back and just, victim blame, essentially saying, oh, well, the company's always at fault or shouldn't be at fault, or, that effectively, I mean, it's still an illegal action. It's still some sort of attacker doing something that's generally at fault. That said, I mean, companies do have a certain duty and responsibility to secure their products. I kind of agree with this guy, but sorry, go ahead, Spectre.
Well, I was just going to say, like, this tweet does seem to be pretty controversial, and one point that I saw that kind of went against Sammy was Lineage is a volunteer project. These people who are working on Lineage aren't getting paid. And I do kind of question if that's, if that kind of absolves you from trying to maintain the security on something that people are using,
it
just
shouldn't,
because you're not getting
because
paid
of that
for
reason.
Maintaining a project. Yeah, exactly. If you're maintaining that project, you kind of have a attached responsibility to that, even if you're not getting paid for doing so. So I don't think I agree with that argument. But sorry, you were going to say something about.
Well, I was actually just going to bring up the other argument that was in here. This guy Jay mentions, I failed to see your statement as being productive. Did you offer to help before and or after this incident? And you're just repeating things you
hoping you would be heard rather than being pragmatic. Yeah. I don't know. I mean,
so he's
not a maintainer on the project, so I don't agree with that argument either, really. It's not, he just because he's calling them out on it doesn't mean he should have been offering help. Like, it would have been cool if he did, but I mean, that's not really his responsibility.
No,
I'm not really sure what the argument is there. It's kind of weird.
Yeah, and I don't. I mean, obviously, I feel like that's kind of sometimes people will. I want to use the term virtue signaling a little bit there. Like, they know a little bit better that you should have done this instead of doing that. And trying to make themselves seem like a better, nicer person by pointing out how you're not. I feel like that's kind of what's going on with that. But keeping more onto the focus there of whether or not Lineage OS should have patches. I mean, the alert went out. It was clearly a serious issue. This is something that you're going to be able to detect with like Shodan or something. So you can expect more. I mean, I'm sure there are other salt stacks that were compromised in this way in the meantime. I can understand volunteer devs maybe not being on top of all the security updates. Like, I could understand how it happens, but at the same
It can be very
time,
easily missed, but it's not really forgiven that it's like ignorance isn't really an excuse, I guess, is the
yeah, that's
mantra you go with here.
kind of what I was going to go with. Is at the same time, it doesn't absolve them from it. It's still something that they should have been doing, should have been on top of, just because people are using this in a fairly sensitive area. I mean, this is managing, in a sense, like managing your data center. You know, it's not a small thing that this is being used for. Although I guess I'm saying that about SaltStack. Obviously, Lineage OS isn't, like, they're using it however they are. I don't actually know. I assume it's part of like their build system. But Lineage OS or SaltStack did the right thing in terms of getting the alert out early, letting people know, hey, best practices, don't do this.
I will say I'm not a huge fan of like that counterpoint either, where it's like, oh, if you're not going to help, then you shouldn't say anything at all. I'm not. I don't think you should have to offer to help on this like massive project to be able to criticize it at all.
I feel
I'm not
like
a fan of that argument.
I feel like we just said that. You just mentioned that, and I just agreed with you that. Yeah, like you don't need to be part of it.
The reason I want to say that is it's not only here that I've seen that argument. I see that argument in a lot of places, not even exclusively in tech. It's just like I just don't really understand it. It's a faulty argument, I think. But sorry, you were gonna.
Yeah, well, I mean, it's like I said. I don't think the word is virtue signaling, but that's the idea I kind of get from it. I'm sure there's a better term for it, but I mean, I feel like it's not necessarily being presented in good faith or without an ulterior motive, I guess. But what I was just going to get at is in terms of, I think, like, SaltStack handled it. They put out the notification pretty quickly. They put out a notification on GitHub with a PDF with a link that you couldn't actually click the link on, which was really annoying. It's like, for more information, here's the URL, and you couldn't actually click the URL. It was like they had a Word document or like I don't know. I don't know what they will have had, and then like printed it. Like maybe even had a PDF and then printed the PDF to PDF again, so it kind of flattened it. So that was a little bit annoying on their side, but apparently they did emails and all that. So the fact that their GitHub message wasn't perfect, I'm not really blaming them for. But they put out the alert really early, pretty much as soon as they could, and then got a patch out as soon as they could after that. So basically giving people the immediate, what to do, and then tried to fix it later. So Lineage OS should have responded to that.
Yeah, I think that's fair. I will say there is a second issue that I'm going to jump back to, and it was in the get token method, which you can access from the same class. This one is like a more trivial issue. It basically takes a file name, but it doesn't validate it against directory traversal, so you can just read files outside of the directory. Now, that file does have to be able to deserialize with their salt.payload.serial.loads method. So there is a kind of a condition attached to abusing that one, but I just wanted to mention that there was that other issue attached to it. Now, because of the impact, even though these flaws have been abused, as we just saw with Lineage OS, they didn't provide any POCs or anything like that. They wanted to kind of make it so it's harder to exploit by script kiddies and stuff like that. Jumping into the timeline. Sorry, go ahead.
I was going to say, at the same time, SaltStack's open source, the commit's fairly visible. I mean, I brought up the one from before, but the diff's available too to see the fix.
Oh yeah, like it's not hard to hit, but it's it's just one of those things like trying to prevent script kiddies that otherwise wouldn't be able to hit it. So that way they can't just.
Oh yeah, it's not just a copy and paste thing to run.
Exactly. Yeah. So jumping into the timeline, so I think you were saying you weren't sure when this was published. It seems from the timeline this was published on the 30th, and the issue was disclosed on the 24th. So it was disclosed on the 24th. The patch was shipped on March 29th. And then it was, publicly disclosed on the 30th. So there is a bit of that. It is under a week for Lineage OS to have fixed that. So,
well, not fixed it, just not made it internet exposed.
or yeah, just not made it internet exposed. Sorry, that's that's a better way of saying that.
Because I mean, that's kind of the difference. I mean, sometimes updates can break things, updates can cause problems. So I could understand at times where updates do take a little while if you want to be certain that you're not going to have any downtime because of it. But making sure something isn't exposed on the internet, which probably shouldn't be exposed on the internet anyhow, I think that's kind of fair. And actually, I do want to jump back, just speaking about the commit and the diff where they fixed it. I'm not going to bother bringing it up on stream, but I will mention that with the code I showed earlier, it was basically whatever command came in, if it was a function on the class and it didn't start with the 2 underscores, it would try and execute that function. That's basically an example of a blacklist. What they've done now is they've moved over to a whitelist. They just have a big list of exposed methods, and basically the method has to be inside of that list, otherwise they won't call it.
Makes a lot more sense to do it that way. That is
a lot more
secure.
Blacklist, you generally just shouldn't use a blacklist because, people try and find their way around it. There's some edge case, something that leads to breaking whatever assumptions you make with that blacklist. Whereas if you have a whitelist, it's a whitelist.
Missing something out of a whitelist is a lot less detrimental than missing something out of a blacklist. Yes. Basically.
Well, it's also it kind of changes the goal from finding some way around the blacklist to basically just much more extreme limit on finding a way to abuse what you're able to access.
Yeah.
I did want to call out just how they patched that, though, which is moving to a whitelist system instead of a blacklist.
Yeah, it's a smart way to go about it. So, with the current world events and stuff like that, online schooling is kind of getting it's kind of soaring in popularity because it's basically all you can do right now. And because of that, ResearchPoint started looking at some WordPress plugins for Checkpoint. What did I say?
ResearchPoint.
Oh, because it's research.checkpoint.com. Yeah, I kind of mixed them up in my head. So yeah, Checkpoint did a post that details some issues they found in 3 of the biggest WordPress learning management system plugins, which is LearnPress, LearnDash, and Lifter LMS. So apparently these are pretty popular. The 3 systems they say are used on over 100,000 websites, including university sites. I think University of Michigan was one of them. There was a few universities they listed there.
Yeah, I mean, given the popularity of WordPress, I'm not surprised. I've never used any of these. I think I've mostly used Blackboard and Moodle.
Yeah, I've looked at Moodle. I haven't used Blackboard, but yeah. So it seems like these plugins are pretty popular, and there's basically 4 vulnerabilities that are detailed in this post. 2 of them are in LearnPress, and 2 and 1 each in the other 2. Well, so
I think there's 5 actually.
Oh, really? Okay, I only saw 4, so maybe I missed one.
Well, so the first one I've got is an authenticated time-based blind SQL injection.
Yeah, that's the one in LearnPress.
So there's 2 in LearnPress. There's also privilege escalation.
Yeah. Yeah, so the SQLI in LearnPress it seems to be fairly straightforward. It's basically just the parameter current items is passed to get items for the search items functionality.
I've just pulled up the diff for the patch, actually. I'm going to change this to split view, which I think I forget how to do that here.
Yeah, I don't really use the split view on GitHub, to be honest.
It's up at the top.
Yeah, there you go.
Anyway, I found their fix your interest. So I initially went and looked at this purely because they don't actually include the details about this vulnerability in the write-up. They basically say, oh, it's straightforward. So they include this information like it's with these parameters, but the technical details of this vulnerability are not particularly interesting. And so they don't really dive into it. Now, I didn't actually take a line number here, so I need to find where I was again. What was the file name? That was or the function name was get items.
Yeah.
Yeah, so their patch is a little bit interesting. So the exploitation details are, as they say, not all that interesting. It does the query, and then in the set here, select meta value. It's basically grabbing the current items in order as item, which is exactly like it comes from the request.
Yeah.
You'll see learn press get request current items. So it grabs that, pastes them right into the query, not using any sort of prepared query or anything. What I thought was interesting with the fix, though, is if you look over here, you do see that they start using a WordPress database repair, creating this prepared query, adding the item in there, and then it's just commented out.
So they fixed it, and then they were like, you know what, we don't need this anyway.
Yeah, I don't know if they fixed it exactly here. Like, it looks
okay. Like, I mean, prepared statements are gonna...
The queries look fine. I'm not sure if it's functionally quite right. Nonetheless, though, I mean, they basically started fixing and then just like, screw it, let's get rid of this feature. And that's the same thing that they did the other vulnerability here with becoming a teacher. They just removed the code for it.
Yeah.
But yeah,
that was kind of fun. You could just become a teacher if you wanted to by just calling the function through the WP admin.
Yeah, it seems like this, the learn press except become a teacher. So presumably this was something like it would email out a link that would lead to hitting this endpoint. So like, you know, you're inviting somebody, they register on the system, sends out a link, they click it and they get the escalate privileges, something like that probably. They mentioned that seems to be more of a legacy or forgotten code. So now you end up calling it and it just, you know, takes your account and gives you the teacher role.
You can just decide to become a teacher. If only it were that easy in real life.
Well, I mean, it is. You go through college and all that once you make the decision.
A lot more expensive, though.
Yes.
Yeah.
But yeah, it's a straightforward issue. In that case, they straight up with both of these just remove the entire blocks of code.
That's like the Sony way of fixing things. Like any PS4 bug that's existed, boom, code just disappears. It's gone. No fix, just gone. So
I mean,
they kind of took that approach.
It works though.
Yeah, it kills the bug because there's nothing there anymore. But it does feel a bit lazy, but you know, whatever works, I guess. And especially in the second case where it's, you know, legacy code and you don't need it, then, you know, reduce your attack surface instead of potentially botching a fix. Just remove it entirely. It makes sense.
Yeah, and dead code is, even if it's not being called, is still a threat to the application because somebody else comes along, is doing some development, and say this dead code has a SQL injection. It's like, okay, you just remove all the references to it. Nobody uses it anymore, but it's still there. Somebody else comes along, they don't know that. They don't know they shouldn't use that function. Then they, you know, write their new page, their new feature, and they call this method or whatever. And all of a sudden you're vulnerable again because you left in dead code and somebody decided to reuse it. So, I mean, removing dead code in general is a good move.
It's generally good practice.
Yeah. But I guess moving on towards LearnDash. And I guess this is where I think we had our different number counts. I see in my notes now that I just had a format wrong and some that isn't a vulnerability. I've got it listed as one. So that explains kind of our different numbers, but unauthenticated second order SQL injection. The SQL injection itself isn't terribly interesting. They have the code for this one. Basically, they've got the first SQL string here, and then the results of that, which is effectively what courses you're in, or that's the gist of it. The results of that, the columns from there, are just imploded into the next query as is. So if you could control what one of those values is, or what the value contains, then you can do a SQL injection because it doesn't do so in a prepared manner.
Which is funny because the first one is done in a prepared manner, but the second one isn't. That's kind of weird. That generally when you use prepared statements, you try to use them everywhere.
It's not as weird though because this is a variable amount of inputs. which makes it a little bit more challenging to do a prepared statement. So you have to inject, say, let's say there's 20 columns and you have to inject like 20. So this uses like the WordPress prepare, which isn't quite the same as the actual, like, whatever's offered by your
PDO
SQL engine.
Whatever it is.
Yeah, WordPress actually just does their own filtering last time I looked and stuff. Nonetheless, I mean, so in this case, you would have to inject, like, let's say you were in 20 courses. One user, they might have to inject that %s 20 times and then provide 20 values in the call. And then another user might only be 14. Another user might be more or less or whatever. The variable amount there. So this is one of those places where I absolutely see or have seen people not use prepared, because it's not like just popping in a single value where just put the %s and put the value in later. This is an array of variable size. Now, I'm not saying it's a good practice to do that by any means. It's just that it's actually kind of common to do that with some of these sorts of trusted data sets also. So I guess going on from there, though, what's interesting, though, is you have to be able to control that course. What is it? The course, is it a course name?
I think it's the course name. This part of the write-up was a little bit weird, I'll be honest with you. It was a little bit hard to follow.
Well, so it's part of the post meta information. So effectively, what the first query does is it's select distinct, replace meta key with learn dash group enrolled. So yeah, it's your courses that you're enrolled with, right? So you need to be able to control that. So you need to be able to control the value of the course ID, which is not something most people are going to have immediate access to. Is where it's kind of a second vulnerability that they use to actually exploit that to get the SQL injection. Because once you can control, effectively, if you can insert anything in as one of those meta keys, then you can do a SQL injection. So what they found was in the IPN, so that's your instant payment notification. So that's like, PayPal, when you get a payment or whatever, it'll hit that endpoint, it'll sign it, it'll do all that magic. What ends up happening is it will take anything out of that transaction. They talk about how they're able to create a request that has kind of the proper values that they want. But effectively, this code ends up just doing it for every value in the request. Updates the post meta information with whatever key they provide. So it's basically a gadget that they can use to insert some of this post meta information, custom meta key, to do the actual SQL injection. So it's a little bit of a roundabout way of getting the SQL injection, but that's generally how second order goes, is you need some other control point also.
But that's kind of cool. I think it makes that issue a lot more interesting. Just the SQLI in itself, it's kind of, straightforward. It's a second order, so you do need to get that gadget, like you were saying. But I think getting that gadget is a lot more interesting.
Yeah,
than the actual
without
issue
it,
itself.
you don't have an issue.
Yeah. So is that what you were saying, where you had 5 issues? Was that ability to be able to change the post the meta information without being authorized? Okay. Yeah, I guess that is kind of an issue in itself, right? You shouldn't be able to do that from an unauthorized context.
I mean, it's just setting some information. It's not necessarily sensitive. It's just the fact that this then ends up being used as trusted information later.
Yeah, it's a link in the chain.
Yeah, so that's kind of the issue. The core of the SQL injection is it's trusting the results that are in the database to be trustworthy. In this case, though, you can show that that query actually doesn't return something that's trustworthy.
And part of why I like those issues, too, is in those areas, like you were saying, even though it might be common to do that, you'll often see, the developer will know, okay, this looks like it would be really stupid to do, so I'm going to put a comment here saying this data is trusted, so it's fine to do this. That's what I often see when I see code like that. So
I can't say I see that when I read PHP code.
Okay, fair enough.
But I think that might be
I just mean
different.
In general, when you see like a code smell, generally if it's obvious, you will see a comment saying why it's okay to do that. And this kind of shows that, maybe there's not a comment there explaining that. They don't. That could be cut off in the code. We don't know.
I mean, data out of the database can generally be trusted to be safe for as database input.
But yeah, that's what I was going to get to, is like, it's one of those things where it's breaking an assumption that a lot of people would have when they're looking at that code. Like, oh, this code is trusted. I'm just not going to look at this anymore. This is fine. Move on. You know what I mean? Whereas this, these researchers kind of looked at it and said, no, wait, okay, let's see if this data is actually trusted. You know what I mean? It's kind of going that extra step, and then, oh, look, there is actually an issue there.
Yeah,
that's why I kind of like those types of issues.
SQL injection is fairly well understood these days, but second order SQL injection is still an issue. It's harder to discover though, which is part of why, it probably doesn't get the attention it deserves. Because, I mean, it's just being found less because it requires much more intimate knowledge of the application.
Yeah. So I think we'll jump into the final issue, which was an arbitrary file write in the lifter LMS. It basically seems to be through an admin table export function, which is in the Ajax handler. So based on the handler variable you pass it creates a new class and tries to generate an export file to a comma-separated values file, a CSV file. Yeah, but it doesn't actually verify that the end file name is a CSV file.
I do want to mention, this is another thing that just feels a little bit hacky, a little bit insecure. Well, so it's in the arbitrary file, right? So with creating a new admin Ajax handler, you register your handler with WordPress and you get called, all of that. What they do is they do a call user function. They have a little string here. That's the LMS Ajax handler, whatever that double colon's called. And
operator. Yeah.
Well, there's PHP has some really weird name for it.
Okay, I'd call it the scope operator, but yeah, maybe PHP.
No, like it's I'm going to look it up here because they use like some Hebrew reference. They use some reference, like it's.
Search for PHP because it looks like you're getting a lot of JavaScript ones.
Yeah.
And Java ones. Because I'm kind of curious now what it's called, because I can't think of what else I would want to call it.
Oh, really. You would not want to call it by this name.
Just another lovely PHP.
Although actually, I think they. Payamian Nectodium, that thing. They only renamed it recently to scope resolution operator. Okay. The error used to actually say like unexpected Payamian Nectodium. I don't know how to say that, but
that seems so dumb. Why would you do that in a language? Nobody knows what that means, man.
Well, at least nobody knows what that means anymore. But yeah, that's definitely an aside thing here. Nonetheless, so they do that, and then they just append the request action to that string and call that as a function. Which, in this case, maybe it's not a vulnerability. I actually did take a really quick look at the code. It doesn't look like it's an issue here because it is only calling, the static functions of that class, so should be fine.
It kind of feels like the last issue, like the last topic we covered. Even though it might be fine now, there probably should still be a whitelist on that. But
yeah. I mean, there's the implicit whitelist of all the functions in there, but I don't know. It just feels like there might be some other way to mess with that when you're able to call any function. Like maybe, a magic function could do something, I don't know, like that's like your __ functions, like toString, deserialize, construct, whatever. Maybe one of those could be called and do something. I don't know. I don't think they define any, so that's probably fine, but
even so, it
just feels wrong.
Something could be added in the future. You know what I mean? That is a dangerous function that they just don't know that can be called from an untrusted context.
Yeah, it generally just feels wrong. It's not the core issue here, or it's not an issue at all here, but it does just feel wrong to me, and I want to call that out. The issue, as you were mentioning, though, is just effectively they call in the request file name, and they generate an export file going to whatever that file name is. So you can overwrite any file you'd like because you can do directory traversal. You can give it any sort of file name you want. You want to overwrite a PHP file? Go ahead. So the only real trick with this one was you had to find a way to get PHP code into what it was going to write. Which ultimately what they used, I believe, was a student name. Yeah, they changed the student name. So it would export the table. It would include the name in there. If they included PHP in the name, they couldn't close the tag because WordPress doesn't let you close. Well, you can either open or close. You can use the open or close angle bracket, but not both in the same value.
Yeah. Now that could be kind of a limiting factor because I think in their POC they basically just use the getInfo PHP function, but generally your name, there's going to be some kind of a length restriction on that. So
not necessarily.
I can see that potentially being an issue here. I don't know for sure, but it's just something that could be worth considering.
Yeah, but odds are you can either control several names. So what you would do was you would do like a part of a command, and then as they do, they end up with the comment, the start comment, and then you would do another name where you would start it off with end comment, more code, start comment, and you can keep kind of injecting
kind of build it up.
Yeah. You could probably do more gadgets or find another area with more text.
Yeah, you could also potentially, depending on how much room you have to work with, do like a remote file inclusion or something like that.
Yeah, I mean, that's kind of off in a lot of systems. URLF open generally isn't allowed by default anymore.
Yeah, could be worth a shot, though.
It could be worth a shot, but I'd say your best bet's going to be just getting your PHP like one-liner in there.
Yeah. So, I mean, most of these issues, bar one of them, was pretty trivial. But I think the way of exploiting them on a few of them also had some cool quirks and oddities that allowed for some like clever exploitation of some bugs that could otherwise be difficult to hit. You kind of got like that CTF kind of vibe to it, of trying to use clever tricks to get around, basically make your exploit work.
I don't know. I mean, they're still kind of normal tricks when it comes to CTFs, but I don't really want to get into that discussion.
Well, I was thinking more with the last issue, you know what I mean? Building it up through the name and stuff like that. That is like a common
Well, we
thing
don't know if there's
in
actually a length on that, though. That was just an assumption you made, so I was
that's
tossing
true. I'm just saying it's like kind of like an issue you would see in a CTF. But overall, like, I mean, the issues are fairly trivial, which isn't too surprising. WordPress plugins kind of share that. They're not generally very secure, and especially these LMS systems, you know what I mean? They're probably not looked at that much. So
I don't know. I mean, I don't know how hard they're going to be hit in the professional sense. But, teenager in high school using it is probably hitting it a bit.
Oh, by students, yeah. And I think they even mentioned, like, that was kind of their, like, motivation going into it. Like, getting into the head of a teenage hacker trying to change their grades or stuff like that. So, that's kind of a fun motivation going into it. But yeah, you're right. It probably should be looked at more than it is. But I know, like, even when I went to school, some of the security stuff they had in place, at least at the time, I think it's gotten better now, was kind of a joke. They just don't really...
but this isn't the school. This is somebody offering the platform.
Oh, that's true. But I mean just generally in that area, it's not considered as much as it should be. You know what I mean?
No, it's not. But
so our next issue is from HackerOne, and it's a domain takeover, a subdomain takeover to Authentication Bypass on Roblox, which I think this is the first time we've ever talked about Roblox on this podcast. So,
I believe so.
Milestone achieved. This one's a very quick one. It basically just seems due to an expired or unclaimed HubSpot instance, they said you could just take over and serve content from devrel.roblox.com.
Yeah, which is because so when you're setting up HubSpot, if you want to use a custom domain with it, you set up a CNAME from whatever domain you want to use, set up a CNAME record that's going to point to the HubSpot domain, which is something like id.sites.hubspot.net or whatever. So it looks like, and I'm not familiar with HubSpot, so I don't know how much control you have over choosing an ID, but it seems like whatever ID they use can now be selected by somebody else, so they can get that same domain that the dev.rel.roblox was being CNAME to. So once you get that, it's kind of clear you now control where this Roblox domain actually goes to, like the subdomain, but Roblox security cookies are scoped to star.roblox.com, so the subdomain does get them. And DevRel is whitelisted to make requests against the chat.roblox API. So they're able, if somebody visits this DevRel website, they're also able to kind of see that user's chat and get some of that information also. It's a fairly simple issue. It's just kind of like, you have some of those older, I presume, dev instances that shouldn't be around anymore, aren't being used anymore, but you still kind of have, in this case, just the CNAME was just kind of left. Nobody really got rid of it. Like, it's an easy thing to overlook. And I thought it was an interesting vector for getting a foothold.
Yeah, it's not one you see, like,
you don't see it too often, yeah. Mostly because, I mean, you don't, I guess you do actually, CNAMEs are being used a lot more with cloud services now, so maybe we'll start seeing this more often.
The kind of a revival of the issue?
Well, I can't really say a revival when it was never never really a big issue, but might see an uptick in it.
Yeah, I mean, the comparison I kind of draw there is like, what's the one that you've been saying a lot on like recent episodes that's kind of wasn't really big back, 10 years ago, but it's kind of rising in popularity?
Well, like CRLF injection and stuff.
Yeah, I think it was stuff like that. I think it was the serialization issues, maybe. I can't remember. But, there's kind of like that comparison that we might see like a rise in them. So, but yeah, overall, like, it's a very quick topic. Just most of the post talks about like the impact, stealing cookies, phishing for credentials, stuff like that.
Yeah, the unfortunate thing is here they have steps to reproduce. Visit the website. I assumed maybe they had more information on their website. Maybe not. Maybe it was just, if you want to reproduce, like, here's proof that we did it, rather than reproducing it.
I think it's just a POC.
But, yeah. Well, you can't even go to it now because they fixed the issue.
Yeah, at least there's like an image there that can show what it was before they took it down.
Which doesn't really matter. Like, I'm assuming it's not actually steps to reproduce at that location. It's literally just a proof of concept that, yeah, we did it. But yeah, I mean, I like the issue just because of how simple it is, but it's not one of those areas that I'm really actively looking at seeing, oh, does this website have, DNS entries for whatever. And I mean, maybe if I did more pen testing, that would be something I looked at more often. At least on the app level, though. It's not. Yeah.
So we'll jump into our next issue, which is in roundcube. So roundcube is it's a mail client. It's not super popular, but I've definitely seen it used, and I've used it in the past, actually.
I used it for years myself.
Yeah. So this issue is, keeping the web issues rolling. It's an XSS that was present in the CDATA, which is basically, it's an interface for character data. It's kind of something that I think people don't really consider, which is why this issue is, present. It seems like they just had a case for handling CDATA nodes when they were parsing the HTML. And they would just echo out the node value unmitigated. So that's where that XSS kind of comes through. In the patch, if you look at the diff, they make it so it now falls through to the XML text node, which does, some filtering and stuff on that value. So it takes away the XSS, basically. The issue itself is fairly straightforward, but it's kind of interesting to see something in roundcube. I think roundcube is kind of forgotten. I think it's lost popularity. I don't think too many people are using it anymore, but
yeah, I know I'm not. I will say, like, the whole point of this function here is that it's supposed to only allow tags with allowed tags with allowed attributes and allowed inline style. So the fact that it did just do this effectively echoing of whatever the node value was for CDATA. It seems like some of that should have been caught maybe sooner. Like, it is a really
It's another thing that
simple.
seems lazy. It seems like something they just kind of tacked on and didn't really think about too much. You know what
Yeah,
I
or
mean?
just forgot to do later because, I mean, it's not a text node, and, if they weren't super familiar, but, I mean, who isn't familiar with the fact that you can put anything in pretty much any node?
Yeah.
Nonetheless, like I said, it's not a hard issue to understand.
Yeah. So unlike roundcube, our next set of issues is in something that is a lot more popular, Trello. I've known a lot of people who've used it, and I actually use it for PS4 stuff. But it's not in like the typical, just like the Trello website. It seems to be in their Butler Power Up, which honestly I hadn't even really heard of. I guess it's not really advertised on Trello very much. But basically, it seems to allow you to define hooks on Trello events. So one of these things that Butler allows you to do is to define additional card buttons for custom actions. And it does that through plugin data. So you can essentially define your own plugins that run through Butler for Trello boards. It's kind of a weird, like, cascading down through multiple systems, but
Okay, so the plugin data, just to be clear, is when you develop the plugin through Trello, Trello can also store data for you, and it'll provide an API, a limited amount of data, but it'll store that for you. It'll provide the uptime for the API, all of that, so you don't have to provide an API. And that's what plugin data is storing, kind of that data, and then it just kind of includes it, or it lets you access it from your plugin later using, I believe it was using post message API, but I might be mistaken about that.
I think you're right, yeah. So the plugin is loaded in an iframe on Trello, and the problem is the button icon field isn't sanitized. The label is, but the button isn't. So because of this, you can just inject code through the custom icon field for the card button. So the actual issue itself is like a trivial
It's a
XSS.
little bit more than that. Part of it was that while the data was sanitized, it was sanitized at the save point. So when it was being sent to plugin data to be, or when it was being sent to Trello to be saved, it would be sanitized there. But you can make those calls manually, so you can add unsanitized data and save unsanitized data that it would then use and trust as though it was sanitized. You can manually make the request. It wasn't just that it didn't do any sanitization, it's that it basically was client side. Or happened like before, yeah.
So I think the part of the problem, though, with this issue, even if you exploited it, was it wasn't super powerful because in order to pull it off, a user needed to open the Butler Power Up from the admin board and basically, use this issue. And that's, it's not like a 0-click or even a 1-click, really. It kind of requires some effort to be able to get somebody to do that. But he reported it and it got fixed. But something kind of triggered him to like revisit it later
and an
on.
$1,800 bounty. So we usually like to include those numbers.
Yeah, you got a fair bounty payer for it. But he seemed to want to revisit it again later. And when he revisited it, one really weird thing he discovered was on Butler, the front-end resources were being served with a path that had the version in the path. And you could actually manipulate that path to use an old version, which included the old vulnerability. This seems like really weird. I don't know why he would do this. I don't know if you've seen this, Z, and any assessments you've done.
It's kind of the idea of having kind of an absolute path. So you write your code against one particular version. And so you have a path that's always going to give you that version of the code. So until you update and you update your dependency, you're always able to use that same version the entire time.
Okay. Yeah, I guess that kind of makes sense. So, like, the main goal of the attack scenario here, it was in this blog post to get Trello to generate an OAuth token on behalf of the user and to be able to steal that token. The thing is, only Trello official plugins typically have that capability, and the plugin they use to load that vulnerable Butler version is not a Trello plugin, so it doesn't have the capability to generate those tokens. But they use kind of a clever strategy to get around that. They basically use the XSS to call functions from the real Butler from their vulnerable compromised one, which could then be used to generate and return a token. So they have a really nice image for those of you who are watching towards the bottom of the post. They have available card buttons and then fake Butler, which they call into the real Butler to get a token, and then they just kind of pass that through back to the fake Butler, and you can generate and steal a token. So it's kind of it's another one of those clever strategies to exploit a trivial issue to do something cool. And this second report still isn't a zero-click, though. You do need a user to add themselves as a member to the malicious board through like an email or something like that. So it does kind of require that phishing-style attack to get that initial foothold. So the payout was the same. I think he got an $1,800 bounty on the second one as well.
Yeah.
But that's cool that he was able to basically kind of use the same issue to get 2 different bounty payouts. That's pretty high IQ.
Yeah, no, I like the attack. Obviously, you got to reuse it there. When it comes to the URLs, I did want to add that probably a better method, rather than just indefinitely serving like those really old versions, is to only serve them, say, for another 3 months after it's been deprecated. Doing something like that, kind of rotating them out so you don't have these really old piece of code, because it was in master-70 was the one that he had the vulnerability in. And the current version at the time of writing was master 197.
I was going to say there was quite a few versions in between.
Yeah, over 100 versions between. So kind of rotating some of that out and deprecating it would make sense. I mean, it's one of those things, like, because other people are depending on some of that code, having that absolute link kind of matters so you don't suddenly break things. But the ability to deprecate, I think, also matters and should be in there. And this is just a case for why.
Yeah. And it's something that it wouldn't take a lot of work to do. You could just script it so that after so many version numbers or so many months or something, send out an alert to that person saying it's going to be deprecated, and then a month later or something, it's no longer accessible. That would probably be a good way to mitigate those kinds of issues and any other products, or even this one, for like future stuff. So the next topic, I think I actually switched to the wrong tab. Let me go back. Yeah, we're still on HackerOne. So this one is an arbitrary file read through the UploadsRewriter in GitLab. So I think we talked about a GitLab issue not too long ago, but it's fun
and
to
it was
talk
another
about
file issue too.
Yeah, it was. So GitLab's fun to talk about because there's a lot of people in our space that use GitLab for obvious reasons. So we're getting into yet another directory traversal issue. Basically, what happens here is they have an endpoint called UploadsRewriter, which is used for copying files when issues are moved from one project to another. But the file name isn't validated and restricted. So if you create an issue with a link to a file name and move the issue, you can specify any file in that link and have the file copied to the second project. So of course, the example they give there is the ... escaping back and doing etc password. That's like your de facto standard. Yeah, it's a good shout. Thank you for mentioning that. So not only did he get a 20k bounty payout out of this, which is pretty crazy. That's pretty high for anything you get through HackerOne. But also, I don't know if you scrolled down and saw some of the comments, but it seems he also reported 2 other issues in GitLab and managed to get an ultimate license. So I didn't know they did this. GitLab has like this kind of added incentive on their program where if you report 3 separate issues within like a certain time period, you can get an ultimate license for GitLab. So that's kind of a cool incentive that I haven't really seen.
Yeah, I didn't know that
programs.
I mean, that kind of goes in line with just like a bit of swag or something. Like it's more than just swag, especially. I mean, what is the actual cost of GitLab Ultimate?
I didn't write it down, but let me try to look quickly. It shouldn't be hard to get.
Yeah, the link didn't work, but
it's looking like it's $100 per user for the gold. They have different tiers of it. They have like free, bronze, silver, gold. The gold is $100 per user per month, and the license they give is per year. So it's probably about $1,200 worth of licensing that you get for free there. That's pretty cool. On top of the $20,000 bounty, you're doing pretty well for yourself, considering all those things combined. So, yeah, always like to cover like GitLab issues though, because it's something that people use a lot. So,
definitely can have a significant impact.
Yeah. So one thing we've talked about on this podcast before is the Google VRP program, especially because they've kind of ramped it up for the COVID stuff. And this one actually came out of last year's VRP, and this one is another XSS, this time in Google Scholar, and yet another XSS in another academic-based system. But this one was through the citations panel, which took a get parameter for loading templating snippets from a relative URL.
Well, so it took a hash parameter, which is it's separate from the get. So the server would never see that. It's part of the location hash.
Yeah. So it seems basically they try to load template snippets from that like relative path. But so normally that wouldn't really be too much of a concern. It's relative, it's controlled. But where it does become a concern,
you're about to say what I was going to
is when you can upload files with arbitrary content, which of course they do because they allow you to upload images. So you can upload content that in theory could be rendered to the page unescaped to get XSS. Now there is, kind of a caveat around that, which is the images that you upload do get transformed and modified by the back end. So one of the things they do is like strip out metadata. They do some reprocessing on the image. So anything that you want to do like an XSS through has to survive all those transformations. So because of that, the VRP team actually initially rejected the issue, saying it's not possible, and they wouldn't accept it without a POC. It's kind of like, that POC or get out, you know what I mean? POC or GTFO. So this kind of turned it into more of a challenge. Like, we have this common theme, I think, over the entire episode where we have like trivial issues that take work to exploit because of just weird circumstances. And this is another one of those. And this post goes through some of the techniques they went through of generating polymorphic images to conceal JavaScript. It kind of feels like steganography for XSS in a way. It's kind of fun in that regard.
I mean, you could relate it to steganography, but still definitely
it's not
pretty
exactly
different.
The same,
I mean, it's obviously a different
goal. It's kind
goal.
of the same idea. Yeah, it's a different goal, but same
you're
kind
encoding
of idea.
things very differently between them, but like I get where you're coming from. And the report here kind of talks about a few different methods of doing that, of trying to encode the payload in there. Only one of them in this case actually worked. They do talk about a few different options there, including putting your payload in the XF data, which, I mean, you really wouldn't expect that to work if Google's stripping meta information. So, of course, that's stripped. Tried having stuff concatenated at the end of the image. Payload, or I don't think one of these, so they can only use JPEG, so they couldn't use this using actually the pixel information to basically set your pixels just right so that it has the code you want. But what they did do was the payload in the JPEG's entropy coded segment, which is basically your like raw Huffman, like the bit stream, the Huffman bit stream. Having the code in there, but they still need to have a way for it to survive some of the transformations being performed. So they've got the data in there. So they played around. They go into a bit more detail about how they try to make it survive. But it was just kind of a manual process of trying different things until they found something. What they do mention, I don't know if you caught this or know what I'm missing, Spectre, but they mentioned that if the first bytes of the image's ECS section were kept, if separated by a pattern of 0 or like hex 00 and hex 14, which makes sense, except when I look at their picture, the pe.jpg, I see that they even highlight the byte 0 or hex 01 and hex 14 and having kind of the byte between that. So I don't know if I am just misunderstanding or if that's just a typo and it actually happened when they used hex 01.
Yeah, I'm not really sure. That part was a little bit confusing for me to read as well. Just, I think part of it is just because I don't really have the background on, the formats of the images. So I was kind of at the mercy of the write-up to try to understand what was going on there. But yeah, I can't speak too much on that, unfortunately.
Yeah, I mean, basically this seems like a little bit of hand waving. Effectively, They found that whether or not it's hex 00 or 01, they found that having those bytes meant that it would survive the transformation. That's the gist of it. Exactly why they don't go into. And to be fair, it works. It doesn't really matter why it works. It just that it works and you can use that. So they were able to inject their script into the image and they had their proof of concept.
One thing I did find interesting about this timeline before we move on is in the timeline you'll notice they found another XSS that used the same technique, and the Google VRP team actually rewarded them an additional payment even after they already submitted the issue, which I didn't know they did. That seems kind of cool.
No, that's something actually. Google's not the only one that does that. That's when we were talking about Mozilla the other day. I mentioned how Mozilla, your payout's defined by what the discussion with the developers has them kind of come to, rather than just on what your report is. But yeah, Google is definitely known for upping the bounty if they find the same issue because of your report. Which
is really cool on them. They absolutely don't have to do that, and most don't do that.
Or if they. Another thing they'll kind of update on, or upgrade on, I should say, is if you have a vulnerability report, maybe that doesn't go far enough. Like, say, I guess this is maybe a bad example of that because they made them provide a proof of concept. But sometimes there'll be something where it's like, okay, and you're able to, get a denial of service, but that's actually exploitable. So here's, money for an RCE. That's maybe also a bad example. I'm kind of thinking of one where somebody didn't realize they could leverage their vulnerability into a RCE. It was a web issue though. It wasn't like a binary denial of service type thing. But I've definitely seen that before too. Like I said, it is cool of them to do that. They're basically paying out what the vulnerability is worth, even if you didn't know when you reported it.
Yeah, I definitely wanted to shout that out. That's good on Google there. So for the next topic, Z, would you be able to cover it? Because I have to do something for like 1 or 2 minutes, and then I'll be right back. So do you want to initially start covering this, and then I'll jump back in midway through or so?
I guess so.
Okay, cool. Sorry about that. I just need a minute or two.
I get to do some solo straight. But yeah, this next issue, it's actually a few issues here off of full disclosure. What we've got are TP-Link cloud cameras, multiple vulnerabilities. There's 4 separate links for this, 3 separate issues. And they're all kind of straightforward and stupid issues that, it's kind of one of those cases of it's IoT. IoT just, the S in IoT stands for security type deal. So what you have in the IP camera binary itself, SW system set product alias check is kind of the method name in particular with this first vulnerability, leading to command injection because while it checks the length of what you provide, it does absolutely nothing to prevent any sort of shell meta characters from being used. So you can just escape the command and add your own command to be run, which is called with set sysname.fcgi. As usual, a lot of our issues here are fairly straightforward. They just don't. I guess they do have a few characters that can't be used. In this case, the dot, at, dash, underscore, white space, single quote, but essentially nothing that's actually going to cause a problem for you. The second issue which apparently I don't actually have the right link for. Hard-coded encryption key. This one I found kind of interesting. What's going on here, obviously, hard-coded encryption key, you already know there's a hard-coded crypto key that's used to encrypt and decrypt a configuration backup file. Simple enough. What's kind of interesting here is less the vulnerability and more what it impacts. What they're using here is DES with ECB. So I've already talked about ECB before on past streams, but DES is, data encryption standard. It's quite old, insecure just on its own. They're using a modified DES. So like they're, in a sense, they're rolling their own crypto based on some old insecure crypto. So it's they do have a little bit of security by obscurity of this, even though the key is hard-coded. To be clear, the key is shared across cameras of the same model, but different models of the cameras do have different keys, so it's not like a universal key. But in order to actually abuse that, you would have to take the time to modify a DES implementation with their modified S boxes and permutation tables, which are just kind of some internal values used when making some of the transformations and replacements while performing the actual encryption. I'm not going to go into all of the math behind that, but that's kind of it's used internally there. I don't know. I hate seeing companies try and roll their own crypto, and this just seems like the worst of both worlds. Like they're using an existing crypto, but it's a bad crypto, and they're modifying it themselves. Now, I have no idea about their modifications and whether or not these modifications actually introduce some additional security or insecurities to the crypto or not. I just know, like, it's definitely a code smell. It's definitely something that you don't want to see. And for any of you guys sitting back, this is not something you should take and run away with as an idea for your own products.
I just got back and managed to catch the tail end of the second issue. Just gotta love the idea of like rolling your own crypto. It's always a solid idea.
Yeah, well, I mean, in this case, though, like they're technically using an existing crypto. They just modify it, which is that security by obscurity. It does take extra work to abuse this. It's just that it doesn't really add much. It's still got
it's a flimsy shield.
Yeah. I don't know. And DS is just old and deprecated. Like, at least if this was 3DS, you can maybe make some sort of little argument on it.
I was going to say, at one point, DES was in, like, the 90s or whatever, used by the governments, right?
Well, yeah, so DES is data encryption standard. It won, like, the NIST competition to be the data encryption standard. Just like AES, Advanced Encryption Standard, won the same competition to be the successor to DES.
Yeah.
So yeah, like it was widely used, but very old at this point and has not stood the test of time. At least 3DS is still, like, it's not considered like great security, but it's still considered sufficient in some cases. I'm not even sure about that. I want to say it was still somewhat, like, it's not something you ever recommend to use. When I'm saying sufficient, I'm saying like it's still, kind of hard to break it with 3DS, but DES itself isn't. But even that, I don't know how hard it is to break now with modern systems. Like, I'm thinking at least like 5 years ago, it was still kind of, it could still be used kind of, sort of, for a short period of time if you don't need protection like 10 years into the future or something. But yeah, it's stupid issue. Plain and simple. Moving on to the last of the 3 issues. Is another command injection. This time in the setEncryptKey.fcgi. So as this method there, HTTP setEncryptKey RPM, which is the handler for that FCGI call. User controlled encrypt key parameter is used directly as part of the command line argument. It's run as root without any sort of sanitization. That's all that really needs to be said. Unless you have something more to add.
No, it's just we've seen so many of these this episode. It's like a theme of the week. We've
Yeah,
got
this
like
episode is definitely very kind of a lot more high level issues than some of our normal episodes.
yeah. That being said, we do have a ZDI post, which I think is another thing we're doing weekly. It's kind of like a recurring thing. I think they're doing more blog posts recently than I remember seeing before. Maybe it's just because we're looking for them more, but it feels like there's been more than past. But this one is a remote code execution in the Microsoft SharePoint using type converters. So Z, do you want to take this one away?
So with this one, it is a ZDI post. As I said, like seem to be covering them almost weekly, which is maybe, because of Ponto, they had some of those guest posts, and this is one of their own posts, I believe. So maybe that's kind of why we're seeing a little bit more now. But yeah, I think we've had one kind of every week for the past few weeks, which I mean is good. They do some great write-ups. Always kind of some interesting stuff. That said, this one is kind of a step away from what we normally see with ZDI. We normally have some kind of deep binary issue. This isn't that. This is in SharePoint, in particular, part of a web application, part of a web UI. What ends up happening here is this is an authenticated arbitrary code execution. So you do need to be authenticated, and you need to have add or customize pages permission on at least one page. So not everybody's going to have that. So some restriction on it, but still code execution. In particular, this is a deserialization issue, which we were kind of touched on earlier, seeing quite a few of them. And it kind of had I won't say a revival, but definitely an uptick following the Jackson data bind issues over in Java. Obviously, this isn't Java, but this is kind of your standard .NET Microsoft product.
Yeah, they're kind of the serialization issues are just kind of. I think more people are starting to think about them and are looking for them.
Yeah, well, I mean, they're being just serializations being used a little bit more now too. Nonetheless, I mean, going into the actual details for this one, it takes a couple steps to get through it. Basically, you're able to provide a web part, which is just this XML configuration file. I believe there is also like a binary version of it, but they just focus on this XML version of it. Effectively, you can tell it, where is it? Right here. Just decodes it to any type. Get export type, the web part pages. Build manager.get type just passes in whatever type name you provide when it's trying to read that XML file. So what ends up happening from there is, since you're able to control, it'll try and convert some string that you provide in the XML into some type using a type converter. So from there, they managed to use system.resource.resx file ref as the type. What's important about that is it takes a string as a value. As we mentioned, this XML is going to have a string as a value that gets passed in. And it'll parse that into two pieces of data. First is a path to a .resource file. And then the second part of that is the .NET type that resource file is to be interpreted as. And that's where the deserialization comes, because what they're able to do is they found the system resource set. And that's the type that could be instantiated using this earlier version, this, what's it called? The type converter. So just to be clear also, that XML string, that's just using the type converter. It is not the deserialization issue yet, but it's because of that type converter not actually being typed to, or allowing kind of arbitrary types, that they're able to get this resx file ref. And then from there, they're able to get the resource set, which it basically takes an input stream, so in this case, like the file name. It'll read that into a stream. Well, it'll give you a stream. It'll read that and pass it into a binary formatter, which ultimately deserializes whatever file you give it. Binary formatter, I mean, if you want to see it's a common gadget for deserialization attacks on .NET. They just use like YSO serial to build up the payload for it, so you could do that yourself. Tools exist to basically automate that part of it. But yeah, the gist of it is getting to the deserialization. I thought it was interesting, just the path they had to take, going through this type converter and then into getting the deserialization from that, rather than it actually being just a direct like deserialization attack.
Yeah, it's one of those issues where the issue itself is kind of like plug and play, but to get there is a process, and that's where you get all like that background information that CDI loves to give on their posts.
I'm not sure I'd agree that the issue itself is plug and play, just because the deserialization is technically it's not like the deserialization isn't technically exposed by the application. You're just using that type converter to get yourself to deserialization, which is then the gadget you can use for code execution. So, like, getting to the vulnerability is kind of a pain too. It's not that straightforward.
Yeah. Now, one thing I did notice in the conclusion of the ZDI post, which I found kind of interesting, was they said the vulnerability was fixed by correcting how SharePoint checks the source markup of application packages. And then it says all 6 SharePoint bugs have the exact same write-up, and they don't have the same severity rating. So some of them are rated as important, while others are rated as critical. So are these 6? Is this just one of the 6 SharePoint bugs? It's just I just see the 6 there, and I'm like, okay, that's kind of interesting because I don't remember seeing that further up.
As they say, they all have. Yeah, I don't remember seeing that any further up either. But as they say, all 6 have the same issue or the exact same write-up, so I'm going to say just slightly different areas to do the same thing. They're just using that same type converter issue.
Yeah.
Because essentially, once they get the type converter, they then follow these steps, using the resx file ref, and to get the resource set to get into the binary formatter. So they use that same chain, so anywhere that's using the type converter is potentially vulnerable.
Yeah, and what you're saying kind of makes sense, because I can see why there could be some different severity ratings there, depending on which ones are reachable from where.
Depending on
some
permissions.
Of them might be more accessible. Yeah, permission, exactly. So I think that's probably the reason, but they do say like the reason isn't actually given of why the severity is different, and they say all of them should be treated as critical. But
I mean,
yeah, I think
code execution's a pretty critical issue.
Generally, yeah, you don't want it. But yeah, so this CVE is okay. They point to another one that was exploited in the wild, CVE 2019-0604, which is actually another one they covered in December last year. I was just trying to see if this one was also being exploited in the wild, but it seems they were highlighting a different one. But they kind of end off their post with saying it'll be interesting to see in the future if this bug is used by criminals in the future. So, that's something.
Yeah, well, I mean, it's SharePoint, so there's definitely the chance of it. Like, it's not like SharePoint is a little used application.
Yeah. Maybe we'll hear some story from Auntie in the future about it being used in some campaign or something. But yeah, we'll move on. So moving away from some of this web stuff, we do have some binary stuff, and this one is actually in Firefox, and it's an out-of-bounds access in JS ReadableStreamCloseInternal. So this seems to be a vulnerability that's in their EMCA script system, specifically when it comes to promise resolution. So I had to look this up because I'm not, super into JavaScript, but a promise seems to be an object that is like an event that expects completion of an asynchronous operation in the future. So it's something you kind of set up now.
Okay, that kind of seems like a bit of a opaque explanation of what a promise is.
Okay, if you have a better explanation,
a promise.
I don't really use them. So
so a promise, like if you've ever done, have you ever done like .then on something and had a callback? So like you would have, okay, so it's a pattern in JavaScript to return a promise, and a promise is a thenable, which is a lovely name, which basically is just, it has a .then. So whatever, if you have like your object, promise object, whatever you put in like .then or .accept, or it's your callback. It's what's going to be called after the promise actually resolves. So it's just a way of kind of writing your asynchronous code, because JavaScript just all runs in that one thread. Like everything's just kind of using the events to yield or take control and all of that, and like go back and forth. So with promises, you're able to kind of write code in a way that's, you can read it in a synchronous way. You can like write a piece of code, then have your next piece of code that needs to run there, and you can kind of read in a synchronous way. It's a pattern that's used. I mean, it used to be implemented by, I think Bluebird was kind of the popular promise library, but now it's actually built into the application. But yeah, the idea is you have the asynchronous function, and you want to actually execute something whenever it's done. It's a way of a function being able to return an object that will contain, or that can contain, the actual result, but doesn't yet, and you'll be updated when it does have the result. That maybe didn't make it more clear, but it added more words to it.
No, it absolutely did make it more clear, because honestly, like I said, I haven't used promise objects. I'm not huge into JavaScript. I don't use callbacks like a ton when I do write JavaScript. It's usually pretty basic. So that's cool that you were able to provide that insight, because honestly, I just looked at the documentation page because I wanted to know like what they were talking about there, and it was just kind of, I guess if you don't use them very often, you don't have that kind of insight. So
I mean, if you
what you provided there was really useful.
If you write JavaScript, you almost certainly use promises.
Yeah, I'm just not a front-end developer, so I have written JavaScript. It's just most of the JavaScript I write is very
well, that's more
basic.
Even back-end to JavaScript, like Node stuff.
Oh yeah,
like it's just in general, because JavaScript doesn't really let you. It doesn't run everything kind of synchronously. You have to use callbacks. So you either end up in like the callback hell, or these promises were a way to kind of try and tackle that. I want to say JavaScript has async in a way now as keywords too. So like it's part of the attempts to deal with the asynchronous nature of JavaScript. Anyway, I think we can kind of move on to the actual vulnerability, which if you want to take that away, or I can.
Yeah, you can keep going.
All right. So the core issue here is that this ReadableStreamCloseInternal doesn't validate the length of one of the containers when it's actually doing the closing. It just uses whatever the original length was. It has a little loop that it's using to write, basically copy the information over from. Has that loop, and the exit condition on that loop is just whatever the original length was. So if you could shrink the container while you're inside the resolve promise call, this function getAs will end up doing an out of bounds write during kind of the next iteration.
It basically seems to be like a time at check, time at use issue.
Yeah, kind of. I mean, it's a little bit more challenging. So what it ends up doing is that most methods won't let you modify the container like that. You can't just make it smaller unless the stream itself is in a readable state. Not closed, not done, or anything like that. So they take advantage of the T algorithm, which is used to kind of like split the streams. And the T reader read handler can be used from inside the resolve promise, and it's supposed to be run asynchronously. Since it's being run as kind of the result of the promise, they had to do some extra work to figure out how to synchronously trigger the read handler. But the gist of it is that inside the T algorithm, it uses its own set of flags, so it doesn't actually update the readable state until after that loop is ended, allowing you to make the buffer smaller when you shouldn't be able to, basically. And they don't go into actually exploiting it like for code execution and everything. It's just the issue there, which is out of bounds.
I mean, this post was by P0, right? And pretty much with P0, with all of their browser posts, they're going to be doing like just straight up proof of concepts. Okay, it crashes, here you go. They're never going to show like a weaponized thing, which is fair, because browsers are, weaponized exploits in browsers are extremely powerful, especially maybe not so much for Firefox, but for Chrome and Safari they are, because of the mobile aspect as well.
I mean, Firefox does have a mobile version too.
And just nobody uses it.
I use it.
Oh, okay. I didn't know that.
I it's not my primary option, but I do have it installed and I do use it on occasion.
Yeah. So they do have a reproduction test case for producing the crash. Now, I will say I'm not, like, by no means am I a, like, hardcore in the paint, browser exploitation person, but I'd say there's probably 2 or 3 browser exploits that I've been, somewhat involved with or written in the past, just, dabbling in it. And I will say this reproduction case is probably the most complex POC I've seen when it comes to browser exploits, because there's just so much weirdness going on because of, like, what you were saying earlier, where you had to kind of make it work synchronously, where it's, doesn't typically work that way. So if you're looking for, like, a browser, like, getting into browser exploitation, this probably isn't a bug you want to start with. This looks kind of like hell to exploit, honestly.
No, and I will mention that I do kind of hand wave over how it does, like, the T-reader read handler is supposed to be run asynchronously, but you need to be able to synchronously trigger it from a promise reaction. They talk about doing that. They talk about these NS auto micro tasks, and when they get destroyed, the thing gets called. I just didn't understand it, so I didn't want to make an attempt at explaining it poorly.
It's complex. It's browsers, so that kind of comes with the turf. But one thing I will, like, add on there is, even though this looks like hell and is probably difficult to exploit, especially if you're new to browser stuff, typically when you look at, like, out of bounds access in browser, it's almost always exploitable. Like, I don't think, like, this is almost certainly could be used for code execution, even though obviously the reproduction case doesn't do that. So if you want a challenge, this is probably quite challenging, and I would say get some experience with browser exploitation before tackling this one. But if you are experienced with browser exploitation and kind of want that, like, next level, this is probably something that could be fun for you to try to do, and you could make, like, a nice write-up out of it for sure.
Perhaps. I mean, I just because I don't know enough, I'm not sure I'd want to actually say it's a good or bad place for somebody to either have a challenge or not, because it might just be, like, stupidly straightforward and I just don't get that, or it might be way more difficult. So
yeah, with that said, we're gonna move on to the last exploit of the stream, and this one is actually pretty big. It kind of blew up, especially in the Twitterverse, and this was by Siguza. So this was an iOS sandbox escape for iOS under 13.5. And it was basically an entitlement ode. And what made this really interesting was, usually when you see anything with iOS, it's very complex. It requires a lot of knowledge of the subsystems that work in iOS. But this one is kind of an exception to that, general rule. There is a bit of there is background on entitlements, which I'll talk about in a minute, but it's not deeply technical. You can understand the issue without understanding how the iOS kernel works, for example, or anything like that.
Well, I mean, saying that, recall where the issue is.
It's a little bit far down because there's a lot of background. I think it's in section 2, the bug, is when they go into the code snippets.
Yeah, I'm just actually going to search for... There we go.
Yeah.
So, I mean, you might not understand it or see what it is immediately here, or maybe you do if you're viewing, but it's not. This is the proof of concept. This is all you need to do the exploit. But I'll let you keep explaining it.
Yeah. So he released this right up on May 1st, and as implied, the bug does seem to be pretty straightforward, and it's basically in how entitlements are parsed for iOS. So on modern systems for sandboxing, you'll have privilege boundaries, right? You're going to have the very common restriction based on UID. You can't access resources of another UID, or you need root or UID 0 to perform certain actions. But iOS and macOS also use something called entitlements, which are basically embedded into the app signature. And these basically specify what an app can and can't do. It's like a whitelist for what subsystems the app has access to.
Yeah, and I will say that this also, I believe, it gets signed by Apple.
It does, yeah.
So that's another challenge here. Like, you can't just add some random security or lack of security. So in this case, you could see the com.apple.private.security.no container. Generally speaking, I'm going to assume you can't just ask for that normally. I don't actually know if you can you.
Well, so the entitlements are signed by Apple, like you're saying, so that apps don't try to give themselves overreaching entitlements. But that's only true in the case of when it's sent to the App Store. You can have developer certificates where the signature is actually managed by the developer, and the signature or the entitlement itself isn't actually signed, but the provisioning profile is signed. So basically, there's a bit of a discrepancy there. So apps going to the App Store, you can't control that entitlement. But with the developer cert, you can control the entitlement, but it's restricted by the provisioning profile. So it's a little bit weird there. And basically, the provisioning profile tries to whitelist what entitlements are okay for the developer certs to have. But the problem is the provisioning profile uses a different parser for parsing the XML than the actual entitlement parsing does. So Apple supports these things calledplists in XML, or property lists. And these basically allow you to use various different containers like dictionaries, values, stuff like that. And what's super weird is iOS has 4 different plist parsers. And in the case of valid XML, they all return the same thing. But in the case of invalid XML, there's discrepancies between the data that they return. So as you can see in the POC, if you're watching the stream, he uses these tokens which are not valid tokens. He uses left angle bracket, exclamation mark, dash, 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 right angle bracket. And that's typically a comment, but there's no actual comment in there. It's just one,
so there's actually
all merge into one.
It's not quite even a valid comment, which is kind of what I found interesting here. So as Spec was just mentioning, it's angle bracket, so open angle bracket, exclamation point, 3 dashes, close angle bracket. So the interesting with that is when you do the open comment, it needs 2 of those dashes. And then when you do the close, it's 2 dashes. So there's that overlap of that one character in the middle that's part of both the open and the close. And I believe that's where the parser differential comes in here, between their 3 parsers that they use. Because you can kind of imagine if somebody were to write the code, say looking for the first index of, as they're parsing through, look for the first index of that angle bracket, exclamation, dash, dash. So the open comment. They get the start of that, and then from that start position, they look for the next occurrence of just the dash dash, like the closing comment. And you can kind of understand if they don't increment it so it doesn't include the dashes from the open, if they don't start looking after that open tag, if they actually include those, then you can kind of understand where this parser differential comes from, where the one parser sees that as also ending the comment, whereas the others don't. Which is kind of the issue that happens here. They do that, and then they do another one that just has the open tag, no overlap, like just 2 dashes in it. That way, it'll see a closed one also on the other systems, but not in the IO kit. I'll let you keep going.
Yeah, so essentially, the validator uses the core foundation property list parser, and then the actual use of the entitlement uses the IO kit one. So the core foundation considers the exclamation point 3 dashes as the start and end comment, where IOKit just considers it the start of a comment. So by using this, you can basically make it so IOKit sees parts of the data that core foundation can't see. So you can kind of sneak entitlements past the subsystem that's verifying, which is called the Apple Mobile File Integrity, AMFID. So there's a really nice little snippet that shows exactly what's going on here, and I'm just going to bring it up on the stream. So you can see they have a code snippet. CF sees these bits, IOKit sees these bits. So you can see that the first bit, or the second bit is basically not seen by the validator. So it doesn't know that that entitlement is there, and you can basically pass arbitrary entitlements to yourself, and using that, you have a sandbox escape. And it's worth noting that these entitlements, there's over 1,000 of them in Apple, in iOS and macOS. There is actually a list that somebody has been compiling that you could take a look at if you're curious, but there's so many entitlements that what you can do here is almost endless in a way, just because there's so many different entitlements. So it's very difficult to manage, which is why, like, especially when you're using different plist parsers, it's just kind of impossible not to have issues here. I do find it interesting why they use so many different ones. Why not just use one? It's kind of weird they would use 4 different ones in different parts of the operating system, but that's just
Probably,
I don't know.
processing things in slightly different, well, obviously it is doing things in slightly different ways, but maybe different levels of input, just different APIs exposed by them led to it. I don't know, but
does say that with valid XML they all return the same data. So it's just
well, what
know.
I mean is
weird.
like if one expects like the file to already be a memory and just takes a pointer and that's the API it exposes, whereas another one expects a file stream or a file descriptor.
Okay, I see what you mean.
That's what I mean by the different formats. And that's just purely a guess, like maybe APIs being exposed are different. Or just, they developed at different times and kind of just used whatever they needed for their purposes, and that's how you end up with the reproduced code.
So this bug, while it is like trivial, like it's not a super technical issue, like it's not a use after free that's hidden deep in the kernel or something, but it is like a pretty subtle design flaw, which is why it probably took so many years for it to get patched. Like I think Siguza said he had this for like years before this was ever actually fixed. I think
I believe he said this was his first
0 day. Yeah. Actually, back in 2017, January 2017 is when he said he found it. So this issue's existed for a while. It's a very subtle design flaw. I do wonder what clued Apple in on this system being broken after so much time. It could just be that somebody stumbled upon it, just like Siguza did. Because I think Siguza was just playing around with app dev, trying to see what he could do with Xcode and stuff, and just kind of stumbled on the issue by accident. And I wonder if that's kind of what tipped Apple off to fix it now. Because, you always kind of had that thought process in your head, like, especially when it's such a subtle design issue, what prompted it, Obviously we can't know. It's all guesswork. Like, I don't even think the post mentions how they actually fixed the issue, because you would have to patch diff, right? Obviously iOS and macOS, they're not really open source, but,
Well, I think somebody mentioned now that this was on Reddit, or no, it's here at the end, I think.
Oh yeah, the patch. Okay.
For the hardening, but basically you just can't have anything inside of your comments. As soon as you have anything inside the comments, it complains.
Fair enough. So yeah, I was wrong. There is actually some patch details in there. I just I must have skipped over it. So cool. Yeah, this was a very cool issue, and I think a lot of people were saying this is like the most clear and stable bug in iOS in a long time, because where it's not at a technical level, like a use after free or anything like that, there's not really any like noise or instability. This is just it's a very simple parsing discrepancy bug, which if you hit it right will have a 100% success rate. It's a very clean bug, which is extremely rare in iOS. So this was kind of like a like a gold nugget kind of in the iOS scene. So it definitely blew up a lot, and I think people are going to end up using that. Sorry, I didn't have my phone.
Kind of like your phone blowing up.
Kind of like my phone blowing up, exactly. But yeah, so it was a very cool issue. We definitely wanted to bring it up, and I do recommend giving it a read, especially because you don't need that super technical background to be able to use it. I'm just going to mute my phone so that doesn't happen again. There we go. Okay, so with that said, though, we can move into some research with Honeysploit. So we only have one research topic this week.
I say research in quotes. It's, you can kind of like, you can call it research. It's a little bit, it's not our normal type of research, though.
I don't know if I'd call this research as much as it's a hoax with statistics attached. That's basically what it is. So the idea behind this blog post is the author is a pen tester and started thinking about how much implicit trust we place in tools as like people in InfoSec, right? So the example he gives is like, POCs and stuff like that you would run against clients. You typically just pull it from GitHub and run it, and I think that's a fair assessment that a lot of people are guilty of that. You kind of place that implicit trust in tools.
A lot of people are definitely guilty of that. When it comes to proof of concept code, though, I mean, like, I always check out the shellcode and disassemble it. Now, that's not because I'm always on the eye thinking about it being malicious. That's just because I like looking at shellcode. I mean, I feel like I've linked my Reddit here before, so like my Reddit's PM me or shellcode. I just like getting shellcode, and I like taking a look at it. So it's always been half of mine, but I know other people that, at least take a cursory look at the shellcode to see what it's doing. And I feel like this code, as I said, it's effectively it's a honeypot in a piece of proof of concept code. So he put it out there, actually several copies of it for several different CVs, as though you can run this script, give it the arguments and it'll compromise whatever target you give it. Obviously using whatever the CV is about. What it actually does is it connects to his own server, and all the commands you run just hit his own server, give you some fake response back, and that's that. So it's a honeypot, but it's at the exploit level. The code he used, though, I will say, I've just pulled it up on stream. It's really obvious that something suspicious is going on here, because you'll notice at the end, socket.socket, and it does nothing with the socket except try and create it, and it creates a raw socket. So like it never even uses the local IP or the port. But it does do an exec shell code, which is, Python execute inside of Python. So like it's obfuscated. It's using hex. So for those of you just listening, effectively all the script does is like print send, and I just noticed this is Python 2 because that's, print without the wrapping brackets. But print sending payload, then it has like shellcode with a bunch of hex, like kind of looks like shellcode. The lines are a little bit long in my opinion. A lot of shellcode would be shorter lines, but shellcode and just appending hex to it, and then in theory you would then send that out. So like if I was looking at this, and like I said, I do generally, because it is a concern, I would mostly just be looking for just a straight up call to like systa or like a popen or something, like clear command injection. I might not immediately get that the shellcode was it, but that exec there, like it's super suspicious. Like I think he could have done a better job at making it look okay. Like even if somewhere in there he encoded like the target port or like the target IP and stuff. It's not those little things. But that said, even though I'm saying that, he had like 2,500 runs of it. So even though I'm saying like I definitely look at things like that, part of that's probably just because I like looking at the shellcode and like figuring out how it works and stuff and seeing if there were any creative tricks.
Your curiosity would save you.
Yeah, but obviously a lot of people did run this and fell into his honeypot.
A lot of script kiddies probably.
So script kiddies, but he mentions specifically several security companies, including Checkpoint, who we talked about earlier, actually, Palo Alto, Verizon, Cigital. And they were using internal IPs to internal hosts, which suggests that either they were just testing this, or they were actually trying to execute it in a client environment. Which I thought was interesting, because I mean, that's of course a concern. If you're in a client environment, you probably don't want to be running sketchy code regardless. Like, take extra care then.
Yeah. So what I'll say here is this post seems to be pretty controversial because I think he says right in it that he got a lot of like kind of hate messages from people for doing this. And, I think it's made more to prove a point than anything, saying, you shouldn't just implicitly trust POCs because they could do stuff like this.
No, and I think it's completely fair what he did. I mean, it's fair game. Exploits going out there, I mean, it's the same thing as having the vulnerable box. It's just another form of honeypot, keeping people on their toes, whatever. I certainly don't, like, oh no, what are your thoughts there? I don't think
I think in practice it is kind of too far, just because, like, yeah, I don't really care if you hit black hats with this or like script kiddies or anything like that. You are going to inevitably end up hitting researchers like they did here, though. And while I think it is fair to expect researchers to be at least looking at stuff before they run it, I don't know. It seems like one of those things where I don't begrudge them for trying to prove a point, but at the same time, it could have had a massive impact. You know what I mean? He doesn't seem like he wanted to be too malicious with it, which is good. But I mean, that is the point, though. So I'm kind of mixed on it. I'm not sure how I want to feel about it.
Oh no, so what's the massive impact that you're thinking of?
Depending on what he made this script do, you could end up compromising, like you were saying, client environments of people who are doing pen testing, which could severely damage the reputation of those companies, of those researchers, stuff like that.
Yes, but
I think it could have massive implications, which is what he's trying to prove. But at the same time, you know what I mean? It does seem like it could be viewed as irresponsible.
I could get that, but at the same time, it's a honeypot that was definitely very limited. It's not like somebody's going to be, I don't know, because I mean, you can't exfil data from it. I mean, you could, but like you're exfilling data that he provides. That's not an issue.
His honeypot specifically, no, but it's one of those things where it's now.
Well, sure. If somebody did something, if somebody did something malicious with it, I mean, malicious exploits exist, and I mean, if you're saying if somebody did something malicious with an exploit, I mean, that's already the risk that's there. His case, so the fact, like you just mentioned, like his didn't do anything and one couldn't have done anything, then that kind of makes it, I think, fair game. Okay. You're executing random code off the internet. If this, like, I mean, you also mentioned kind of just the cat being out of the bag, but it's already like it's not a new idea.
Oh, it's not a new idea, but it does bring attention to that idea.
Sure, I mean? But I mean, I wouldn't place like, even if some attackers were to actually start doing this to compromise security experts, I wouldn't put the blame on him for it.
Yeah, that's fair. I mean, I will say that a lot of the people that were complaining about this post and sending it hate were probably just people who got hit by it and were salty. You know what I mean?
Well, like he mentions, like getting DDoS or whatever early on. Now, I did find it interesting that some threat intelligence companies actually kind of tweeted out the proof of concept, and he calls those out, and I kind of get it. Like, one of them says something along the lines of like, our sensors detected this proof of concept, rather than this is a working proof of concept, just this is now kind of out there. We believe this is out there, not verified or anything. But he does kind of call out some of those places as publishing and publicizing his exploit, or his fake exploit.
I mean, you know what this reminds me a lot of? Obviously, this is a little bit off topic. This isn't really what we talk about, but there was a huge story, I think, like last year or the year before, with like a big story of a university team that put out like a hoax study. There was a study, like it was a paper that was completely like wrong. It had a lot of factual inaccuracies, but it ended up getting accepted by the academic community. And
well, it wasn't even wrong. Kinda, I know the one you're talking about there. It was like just made up.
Yeah.
I mean, I guess you could say it's, yeah, go ahead.
Yeah, but it was meant to prove a point. It was meant to say like, hey, there's, a failure in our systems here, and the fact that this got through is kind of trying to demonstrate that point. And that study and the people who did it ended up getting a lot of hate for that. And this is kind of like that for the security area, not as big and not as like socially impactful, but I think it can you can draw a comparison there between that and this. I think I wish I knew the name of like the study or whatever that did that. I can't remember it, but it reminds me a lot of that, like anecdotally. You know what I mean?
Yeah, I mean, I definitely see some differences though, just in the sense of, that's talking about the peer review or lack of peer review before being accepted to an academic conference. Whereas this is just, researchers running code they found on the internet that does something they need right then.
Well, it's also the reason I draw that comparison is what we were saying with the intelligence, companies that are just tweeting this out as if it's like a credible thing.
Well, that's the thing. A lot of them weren't necessarily saying it was a credible thing, just it was detected that it's out there.
Okay, maybe it's more accurate to say it's implied that it's, because most of the things they tweet out are legitimate, right? So when you see something that isn't, without actually looking at it, you would probably assume it is legitimate just based on the history of what they report. You know what I mean? So it's kind of implied that they're vetting it, even though they might not be. You know what I mean? It kind of breaks that assumption.
I get that, and that's kind of why I also just called it out too. Like some threat intelligence teams did tweet it out, and that helped it get some public, get a greater reach, was because it got tweeted out, because people saw it as being a legitimate thing without having actually run it and tried it.
So with that being said, I think we'll start to wrap up the show. We'll move on to our shoutouts. Z, you had one of a blog post, guys 30 reversing tips and tricks.
Yeah, which is just that. It's just some RE tips and tricks. Nothing too crazy, nothing that's going to be like, oh my gosh, this changes everything. It's just seems like somebody that does some RE that has a handful of basic tips and just little things. I mean, some of it's simple, like, looking up constants and stuff for finding crypto. But I thought it was interesting nonetheless. It's a tweet, or a bunch of tweets, so it's kind of up as a blog post here, but yeah, I thought it was kind of interesting.
Yeah, it seems to have a few like pool tips. Like I'm seeing a lot of like IDA ones. Like
it's example, IDA heavy.
Yeah, like IDA's assembler, you can use the numpad plus and minus keys to change the number of arguments passed to a function with variable arguments like printf, which I actually didn't know. That's kind of cool. So it's a lot of like tool-based tips, but still, like there's definitely people out there that'll find these interesting and helpful. So wanted to shout it out. Like you were saying, nothing earth-shattering, but probably new to at least some people out there. Like that tip I just mentioned, I didn't know, so that's new to me right away.
Yeah, that's the thing. Like there's just a bunch of little tips there. Probably something you don't know, maybe not, but like I said, nothing that's crazy. Just it's there. It's a shout out.
It's not a super dense list. You can go through it and say, oh yeah, I knew about that one. Oh look, that one's new. Like you can just like kind of scroll through it in like a couple minutes. You know what I mean? The next shout out we have is from C-Turd, and he actually did a blog post about getting remote code execution on Nintendo 64 through a game called Morita Shogi, which I think is just like the Japanese shogi board game in like game form for N64.
That you can play online.
Yeah. Now that term remote is what makes it so interesting, because apparently that cartridge was the only game to include a built-in modem in the cartridge for online play. Which is like, that's pretty cool. I didn't know there were any N64 games that did something like that. It's like really novel and innovative. And another thing that was interesting is because this hardware was so unique to that game, N64 emulators don't support it because it's not really common. It's only that one game that does it. So all the testing that he had to do for hitting this bug had to be done on a real Nintendo 64. So in the post, he kind of goes through the reversing that he had to do to try to pull feedback from the console, and he found that the game had debugging statements left in it and stuff like that. So it goes through the whole process of what he did to debug that exploit, and how he found the actual issue, which is a stack overflow in the phone number field of the save game, which isn't surprising. Save games are kind of like the biggest attack surface when you're talking games, especially games that are that old in the N64 era.
Yeah, especially when you don't have like ASLR and stuff to deal with. It's definitely a big attack surface.
So it's another one of those fun posts that talks about hitting a very old system, so it's not like a modern exploit or anything like that, but it has that cool old retro factor to it, and it also has the background information that most people don't know. It's pretty niche. Most people don't look at like a Nintendo 64 in 2020, for example. So it's got some really cool insight in there. And, obviously I have to give C-Turd a shout out because, he used to do PS4 stuff, and his write-ups are really good. Usually very thorough, give a lot of background knowledge. they're few and far between. He doesn't do too many write-ups, but when he does, they're definitely worth shouting out, so that's why we're shouting it out here. That being said, I think pretty much wraps up all of our shoutouts. Did you have any additional ones that you had like last minute, Z, or anything like that?
Nope.
No, you're all good. Okay. So we'll wrap up the show there. I will say once again, if you didn't catch the beginning of the podcast, we are going to be doing a blog post on the different decompilers we've looked at and some of the points that we found with it. So we are going to be doing like a more, structured blog post at some point. We'll let you guys know. We'll put like an alert out on the Discord and on Twitter and stuff like that. But thanks to everyone who tuned in. You can catch the VODs on Twitch or on YouTube 24 hours after the stream. We have the previous podcasts up on Spotify as well as Apple Podcasts, Google Podcasts, and we have an Anchor FM as well that you can check out. I may be doing some streams at some point this week, doing some PS4 stuff, because if you haven't, if we have any PS4 or people who like PS4 stuff listening, there is like a planned, release in the very near future within a week or so. So I might be doing some streams looking at that stuff. I don't know, but I will let you guys know if I am. You can also join our Discord or follow us on Twitter if you want to get involved in the community. But other than that, we will be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific, for the episode 41, Hex 41 of the dayzero podcast. And we will see you guys then.